So for our third and final problem, we have here this problem. It's quite a lengthy one. Let's try to read. Okay, so we have here Peter plans to create a bee house in the shape of a regular hexagon and place it on a rectangular platform as shown below. On the figure, we have here hexagon is the top view of the bee house with a side length of 4 meters. QRST is a rectangular platform. So what is the area of the blue shaded region? Okay, so for this problem, we've already identified the problem that we have here, and we also need to understand the problem. Okay, what are we trying to solve for this problem? What is the area of the blue shaded region? So how are we gonna get the area of this blue shaded region given that we have a regular hexagon inside or inscribed in this rectangle? Okay, so that's the understand part, and we've already understood the problem. We just need to find the solution and the answer for our given problem. Okay, so we've already understood the given problem, and we have understood as well the thing that we want to solve for this problem. We want to find the area of the blue shaded region of this rectangle that we have here, given that we have here two polygons. We have here a hexagon and also a rectangle. And if for you, you guys who don't know, so a rectangle is also a polygon. Okay, and then we have here our solution, and then for our answer, we're gonna give it as well for this one. So we've understood the problem, and we've also understood what they're asking us for this problem, the area of the blue shaded region. For the first step, okay, so for the first step, we first need to find the area of the hexagon. So how are we going to solve the hexagon? The hexagon here, given on this problem, if you didn't memorize, or if the area of the hexagon wasn't given in your exam, or if you haven't memorized it, so that's okay. There is a method in which you can find the area of a hexagon just by finding the area of one triangle on the hexagon given. And this is just not a normal hexagon, this is actually a regular hexagon. In a regular hexagon, all of its sides are equal. So given here on our problem, the measurement of one side of the hexagon is equal to 4 meters. So if that's 4 meters, so therefore this hexagon right here can be divided into 6 equilateral triangles. Okay, so there you go. So those are 6. Those are 6 equilateral triangles. And if they're equilateral, so that means all of these sides must also be equal to 4. Okay, so this must be 4 meters. This must also be 4 meters. So this is also 4 meters, 4 meters, 4 meters, and 4 meters as well. And we have seen that the diagonals of this hexagon is actually equal to 4 plus 4. Okay, so one diagonal of the hexagon is gonna be equal to 8 meters for this problem. Okay, so for this one, to solve for the area of the hexagon, we just need to find the area of one equilateral triangle, and then we multiply that to the number of equilateral triangles that we have here for this hexagon. And for this hexagon, of course, we have 6. Okay, so how can we find the area of one equilateral triangle? So that's gonna be our second step. If we look at here, guys, so this is an equilateral triangle, so that must mean the measurement of all of its sides is equal to 4 meters, and therefore if we draw a perpendicular bisector here, we're gonna create a 90-degree angle. Okay, if that's a 90-degree angle, so this must mean that the 60-degree angles that we have here, so since this is an equilateral triangle, it's also an equiangular triangle, so all of it is equal, all of the angles of this triangle here, triangle GOA, if this is point O, is gonna be 60 degrees. So therefore this 60 degrees right here is going to be bisected. Okay, so that means it's going to be divided by 2. So therefore the measurement of angle, let's say this is point Y. Okay, so let's say that's point Y. So therefore the measurement of angle GOY is gonna be 30. Okay, so therefore we have here a 30, 60, 90 special right triangle. Okay, so therefore if the measurement of this triangle of the base is equal to 4, so that must mean if it's been bisected, this is gonna be 2 meters. Okay, and let's just remove the m there so that we don't get confused. Okay, so therefore if this is a special right triangle, a 30, 60, 90 triangle, Okay, so therefore, we can find the measurement of these two sides if we know the formula for finding the sides of a special right triangle, specifically a 30, 60, 90 special right triangle. So if we have here the special right triangle, if we have here a given side which is equal to S, okay, so therefore the side opposite to 90 degrees, okay, so this is the side measurement of the special right triangle that we have. So therefore, if this is 90 degrees, the side opposite to 90 degrees is going to be 2S. The side opposite to 30 degrees, that's just going to be S. And the side opposite to 60 degrees, that's going to be S square root of 3. And we've already identified the side measurement opposite of 30 degrees, so that's equal to 2. So therefore, we can get the height. We can get the height of this equilateral triangle, or the measurement of this side of the special right triangle that we have here. So that's just gonna be 2 square root of 3. Okay, there you go. Because the side measurement is equal, the side measurement here, 4 divided by 2 is equal to 2, and 2 times square root of 3 is just gonna give us 2 square root of 3 for the apothem. So we call this the apothem. Or we can also call this the height. The height is also called the apothem, or the height of the equilateral triangle that we have. Okay, so that's our third step that we have here. Okay, so now that we solve for the height of our triangle here, or the apothem, that's equal to 2 square root of 3, we can find the area of one equilateral triangle. So that's 1/2. Okay, 1/2 times the base multiplied by the height. And we know that the base is just equal to 4. As we've seen here, this base of this equilateral triangle is equal to 4. And then we know that the height, as we have solved, is equal to 2 square root of 3. And what's 1/2 times 4? That's just 2. And 2 times 2 square root of 3. So therefore, the area of one equilateral triangle is equal to 4 square root of 3 squared meters. Okay, and then to solve, if this is the area of one equilateral triangle, we can solve for the area of the hexagon itself. Okay, so therefore that's gonna give us 6 multiplied by 4 square root of 3 squared meters. And what's 6 times 4 square root of 3 squared meters? That's gonna give us 24 square root of 3 squared meters. So there we go. So therefore that's the area of our given hexagon that we have here. So now that we know the area of the hexagon, how can we find the area of the rectangle that we have here on this given problem? Okay, so we have here our fourth step. Okay, so for our fourth step, we've identified the diagonals. Okay, the diagonals here measure 8 meters. And if this is a diagonal, okay, that long line here from O to X is parallel to line RS. And if they're parallel, so therefore, they must be equal to each other. So OX is equal to RS, and since OX, the diagonal, is equal to 8, so therefore RS is equal to 8, and therefore the width of this rectangle is equal to 8 meters. So how are we going to solve for the length? Okay, solving for the length of the triangle, so this is for the width. Okay, so solving for the length of the rectangle, I'm sorry. So we have here the rectangle. Okay, the rectangle, okay, if we focus here on one triangle, so it has an apothem or a height of 2 square root of 3. So therefore, this side must also have a measurement of 2 square root of 3 since they're parallel to each other. So if that's 2 square root of 3, and this is also 2 square root of 3 if we add them, so therefore that's going to give us the length of the rectangle is equal to 4 square root of 3. Now solving for the area of the rectangle, so we have here area of rectangle QRST is going to give us length times width. And we know that the length is equal to 4 square root of 3. If we multiply that by 8, that's going to give us 32 square root of 3. So therefore the area of our rectangle here is going to be, okay, so the area of the rectangle is equal to 32 square root of 3 squared meters. So now that we know the area of the rectangle and we also know the area of the hexagon, we can now find the area at long last of the blue shaded region that we have here. Okay, so how can we solve for that? We just find the difference of the of the area of the rectangle minus and then the area of the hexagon. So that's gonna give us the area of the blue shaded region is gonna be the area of the rectangle itself minus the area of the hexagon. And we know that the area of the rectangle is equal to 32 square root of 3 squared meters, and we have the area of the hexagon, so that's equal to the one that we've solved a while ago, so that's 24 square root of 3 squared meters. And what's 32 square root of 3 minus 24 square root of 3? That's just gonna give us 8 square root of 3 squared meters. So there you go. So the area of the blue shaded region for this rectangle is just equal to 8 square root of 3 squared meters. And that's how we solved it.